Dear students, today we'll see what do we mean by woofers and tweeters. Now these are the extensions of loudspeakers for lower frequency signals and high frequency signals. So here our topic for the day will be woofers and tweeters. Now what is exactly woofer and what is exactly tweeter? That we are going to see in our today's topic. So now, to understand this, first we will again remind ourselves about how was a loudspeaker working. How does a speaker work? So here, if you see this diagram, okay, so you are having a permanent magnet here. Permanent magnet whose north pole and south pole are named as N and S. So here you can see N in between and S you can see at the sides. Okay, so this is your permanent magnet. Okay, so this is your permanent magnet. So here you can see your N type pole, and here you can see S type pole. Here you can see S type poles. Okay, so between north and south pole of the magnet, you have this magnetic lines of force. Magnetic lines of force. So there is a magnetic field here. Okay, so all this is magnetic field, and in that magnetic field, you have placed this voice coil. This coil and this coil here. Okay. Now to this coil, you're going to give a electric signal. Okay. The audio signal, which is in the form of electric, that will be given to these coils. Then when the electric current of that signal passes through this coil will develop its own electromagnetic field. Electromagnetic field here. So this magnetic field of the coil, which is the electromagnet, and the permanent magnetic field, which is there, these lines of force from north to south, okay, they will interact, and the coil start aligning itself. And the coil with the small attachment called a spider will be connected to a cone, will be connected to this cone. This cone is nothing but the diaphragm. This cone is nothing but the diaphragm. Now, as the coil vibrates itself depending upon the input electrical signal, okay, so change in that electrical signal will change the electromagnet of the coil, and that magnet will start aligning with this permanent magnetic field, and in that process, the coil vibrates, and that vibration is transferred to the diaphragm, and then this diaphragm connection will give you a output from this dome, which will be your sound waves. This will be your sound waves. Okay, so electricity or electric energy is converted into sound energy. This is what we saw basically for a speaker or loudspeaker. Okay, now when we come to see what is woofer and tweeter, then we are a differentiating speaker on the basis of input signal frequency. Okay, so the electrical signal frequency, the electrical energy, which was earlier converted from sound to electrical by the microphone. Okay, now that electrical energy, if it is having low frequency, then you should have a speaker in terms of woofer. It will be called as woofer. And if the frequency is very high frequency, then you should have a speaker in terms of tweeter. Okay. If the frequency is very low, then you can have subwoofer. And if the frequency is very high, then you can have super tweeter. But woofer and tweeter will be on the opposite ends of the frequency spectrum. And in between, in mid range, you can have mid range speakers. Okay. So here, if you see the basic speaker, a larger speaker or woofer produces the lower frequencies, while a smaller speaker or tweeter produces the higher frequencies. This is how they are going to convert the low frequency and high frequency into sound waves. In such a way, two-way system, a passive electronic circuit called a crossover network is employed to direct the higher and lower frequencies to the appropriate loudspeakers. That means if you're having a speaker And if you are having a multi speaker in which you are having woofer also, mid-range speaker also, tweeter also, then you should have some circuit called as crossover network, which will separate this frequency signals, and then it will allow the low frequency go to the woofer, the high frequency go to the tweeter. Now if you see internal or diagram of a speaker over here, so here you can see you are having a speaker in this box, and then here you are having your electrical connections. This is your external connection from where your electrical signal will be going. Okay, now this electrical signal in this crossover unit, which this is a crossover unit where you can have inductors and capacitance, where inductance will pass DC and block AC, whereas a capacitance will pass AC and block DC. So after that, we can see you can have way like signals of high frequency will go to the tweeter. So here you can have signals of high frequency going to the tweeter, and then signals of middle frequency going to the mid range, and signals of low frequency going to the woofer. So here you can have your low frequency which are going to the woofer, middle frequency are going to the mid-range speaker, and this high frequency are going to the tweeter. And here and here and here, all the three places, the basic principle of working of the speaker will be same. You will be having a voice coil placed in the magnetic field, and the voice coil will be given the electrical signal. When the electrical signal reaches the voice coil, it will form its own electromagnet. That magnetic field, when it interacts with the permanent magnet, that will align itself or start vibrating. That vibration is connected to a diaphragm. The diaphragm will vibrate, and sound waves are generated. So this basic principle will be more or over same in tweeter, mid-range, and woofer type of speakers. But they are going to be different in terms of their construction, because they have to handle low frequency, middle frequency, and high frequency. Woofer have to handle low frequency, tweeter have to handle very high frequency, whereas the middle frequency is handled by mid-range speakers. So here if you exactly see the frequency ranges, woofer speakers designed specifically for low frequencies, that is less than 200 hertz. So just remember this, woofers are designed for electrical signals who have frequencies less than 200 hertz. Then mid-range speakers are designed to accommodate frequencies ranging from 500 hertz to 3000 hertz. Then you have a tweeter or dedicated speaker type specifically designed to handle frequencies above those of mid-range frequency. That is above 3 kilohertz, whatever is there will be handled by tweeter. Okay. Now, if you're having very low frequency, lower than what woofer can handle, then in that case you can use sub woofers with your woofers. And if you're having very high frequency, then that what the tweeter is handling, then you can have super tweeters for that. Okay. So those are the extensions of woofers and tweeters. Now, if you see the diagram of a crossover network and the speakers, then you can see here, the first we have shown is a tweeter. Okay, so here you can see you are having a tweeter. Now, tweeter will have only a capacitor because it has to pass only high frequencies. High frequencies. Okay. Then you have a mid-range speaker over here. This is your mid-range speaker. Now in this mid-range speaker, you are going to pass the middle range frequency though. So here you have a combination of C and L, which will pass the middle frequency, mid frequency. Then you have a woofer here, which will be larger in size. Okay, and it will be handling very low frequency. So this is an inductor here, which will block high frequency and pass very low frequency. So here very low frequency are passed. Okay. So from this main connection of electricity here, main connection, you are going to separate them based on your L and C combinations, which are called as crossover networks. and give the appropriate frequency to the appropriate speakers. The speaker which handles high frequency is smaller in size as the tweeter shown here, and the speaker which handles lower frequency is larger in size as the woofer shown here. Similarly, you can see the frequency response also. In a tweeter, you are only handling high frequency here. In mid-range speaker, the mid-range frequency range is just below the tweeter, and below that, low frequencies if you want, then you have to go with woofer. Okay, so this is the diagram which shows all the three frequency ranges. So here we'll see that low frequency speaker is called a woofer and the high frequency speaker is called a tweeter. In a few systems, there are separate subwoofers and sub-tweeters to reproduce the extreme of that. Means any low frequency is there, it will be reproduced into sound by the woofer. But you have very low frequency, then you have to use subwoofers. If you are having a high frequency, it will be converted into sound by tweeters. But if you are having very high frequency, then you have to use super tweeters. There is a modification there in terms of diaphragm and the size, so that a lower frequency is handled by subwoofer and very high frequency is handled by super tweeters. Then if you see practically a speaker, it looks like this. So here you have shown the speaker. Now here you can see one speaker is there. This is another speaker. Okay, so this is another speaker here. So here you can see one more speaker. So multi-speaker system. This is a multi-speaker system. Now the first one which we have connected here, it is the mid-range speaker. This is the mid-range speaker. The second one you have shown here, very small ones. It is a tweeter. It is a tweeter. And the third ones, which are bigger ones here, those are the woofers. Okay, so you can see that in a single box, in a single system, you can have all the speakers fitted and you can have the enjoyment of hearing the sound, whether the sound input signal is very high or low, that is bass or very high R frequency. Okay, so there you can have the clear sound for all those frequencies. Okay, the whole below is the lowest woofer and it is a port for a bass. So below you see a lowest smaller this thing. Okay, this is a smaller woofer for a bass reflex system. Okay, then these are the diagrams of woofer where you can see a larger diaphragm. So if you see the construction part of it, a woofer is a speaker that is sized and constructed so that it can reproduce low and mid-range frequencies. Woofers do most of the work in reproducing the frequencies you hear, such as voices, most musical instruments, and sound effects. Now, for handling low frequency, the size of the diaphragm also should be big. So, the better example will be the diameter of the diaphragm will be around 12-inch, and the movement of the diaphragm and the movement of the voice coil is lightly attached. It is lightly attached. It is not very tightly attached to each other. It is lightly attached so that movement becomes flexible. So here a woofer is larger in size with a larger diameter diaphragm. So here you can see a good a woofer might be around 12 inches in diameter or more. There are a couple of reasons for that. First of all, the speaker has to move slower and the diaphragm, that is the speaker cone, has to move further to create the sound wave. Secondly, the speaker must produce a higher volume of sound as low frequency sound waves don't travel as the high frequency ones do and are much more likely to dissipate and be absorbed by the surfaces they come into contact with. So here, general idea what we'll be having is a woofer will be having a larger size. Its a diaphragm will be around 12-inch for a better woofer in diameter. Okay. Secondly, its a connections with the voice coil and the dome outside will be very loosely connected so that any vibration in the voice coil will be converted to the diaphragm and then it will be converted into sound waves. Okay. Then what is subwoofer? Subwoofer reproduces very low frequency frequency lower than what woofer can handle and is used mostly in home theater surround sound applications and high-end audio. This you can see a picture of subwoofer. Then what do we mean by a tweeter? A tweeter is a specifically designed speaker that is smaller than a woofer. Its a diameter of its diaphragm is smaller than that of a woofer. It only reproduces audio frequencies above a certain threshold, including in some cases sounds that human ear cannot hear but only sense. Those sounds also are being put out by the tweeter. Okay. So, because high frequencies are highly directional, or tweeters disperse high frequency sounds into the room so that the sounds are heard accurately. If the dispersion is too narrow, the listener has a limited amount of listening position options. If the dispersion of sound is too wide, the sense of direction of where the sound is coming from is lost. Okay. So, because of this, high frequencies are highly directional. So, our tweeters have to manage that. Okay. Then there are different types of tweeters which you can see. The first one you can call it as a cone tweeter, a smaller version of standard speaker. Then the most famous, the dome tweeter. The voice coil is attached to a dome that is made of fabric or a compatible metal. Then you can have a piezo tweeter. Instead of a voice coil and cone or dome, an electrical connection is applied to a piezo crystal. Piezoelectric method is used here, which in turn vibrates as a diaphragm. Then you can have a ribbon type of hot tweeter. So instead of a traditional diaphragm, a magnetic force is applied to a thin ribbon to create sound. Then you can have electrostatic type of tweeter in which a thin diaphragm is suspended between two metal screens. The screens react to an electrical signal in such a way that the screens become out of phase. This alternately attracts and repels the suspended diaphragm, creating the needed vibration to create sound. So these are the types of hot tweeters based on their constructions and diaphragms. Then we come to see what is a super tweeter. A super tweeter is a speaker driver intended to produce ultra high frequency. So a tweeter can handle high frequency, but if you want ultra high frequencies to be converted into sound, then we can go for super tweeter. Then it is handling ultra high frequency in a multi-driver loudspeaker system. Okay. Thank you, students.